In this problem, we'll be multiplying a multivariate polynomial by a monomial, as Alex calls it. So basically distributing this monomial here to each term inside the parentheses. And this is what it looks like. Negative 2xy to the fourth times 5x to the fifth. And then we'll take that negative 2xy to the fourth again and multiply it by 3x squared y to the sixth. And we'll take that monomial again, negative 2xy to the fourth, and multiply it by negative 8y to the sixth. And so then what you do is take each like this and look at the numbers first. So we have negative 2 times 5 is negative 10. And then x to the first, basically, times x to the fifth is where we add the exponents, x to the sixth, and that y to the fourth stays in there. Then for this, we have negative 2 times 3, and that's negative 6. X to the first times x squared, that's x to the third. And then for the y's, y to the fourth times y to the sixth is 4 plus 6 is 10. And then we have a negative times a negative, and that's a positive. So 2 times 8 is 16. And then you have the x. And then y to the fourth times y to the sixth. So that's where you add the exponents. 4 plus 6 is 10. And that's it. These are all unlike terms. So that is all of your answer. So remember to be careful when you type in your answer that you have every little thing correct so Alex can recognize your answer. In the next type of problem, we're multiplying binomials with leading coefficients of 1. So this, remember, bi means 2, mono means 1. So binomials is where we have 2 terms, and we're multiplying 2 of these binomials. So this involves a bit of a process that is often called FOIL. If you remember foiling or using FOIL, F-O-I-L, I'll show you how that works because that helps organize your distributive property. So what we're basically doing is using the distributive property again, where we multiply 4 times each term in the parentheses next to it, and also the u times each term in the parentheses next to it. But again, FOIL organizes your distributive property. It helps you to stay organized. So we write down FOIL, and then once you get used to this, you get faster and you don't have to write FOIL. You can see it in your mind and do it, so wherever you're at is just fine. So F means first positions. The first positions is what you look at right here in these parts of the parentheses. So that's u times u. So I'll write that so you can see exactly what we're multiplying in your notes, and u times u is is u squared. So F for first, okay? Now for the O means outer. Outer is this u and this negative 3. So we're multiplying the u and the negative 3. And we always multiply these things. The letters tell you where to go in the parentheses. So u times negative 3 really is negative 3u. And I'll show you what to do with these in the next step. I for out for inner. And so I'm going to erase those arrows, and the inner positions are right here. So that's 4 times u, which is 4u. Okay, L is for last. And the last positions are right here. So that'd be 4 times negative 3. The internet will not let me write. So let me try that again. Okay, which is negative 12. So first positions, outer positions, inner, and last. So keep in mind what those are. We'll do it again over in this example. Now what you do with these is, I'm going to write this right here, or right up here. We line them up. U squared minus 3u plus 4u minus 12. Line them up with their signs. And then we look for like terms. A lot of times there'll be like terms that we can combine. So the u squared stays in there. Negative 3u plus 4u is plus 1u. And then we have that negative 12. And this is your answer. So what I'm going to do is grab another slide and put that problem on this slide so that I have more room. Pardon me while I do that. You can take a look at this a little more. We'll do it again. In this example, we have w minus 8 plus times w plus 3. So FOIL, okay, first positions is w and w. W times w is w squared. The outer positions is w in the 3. W times 3, and that's 3w. The inner positions are right here, negative 8 times w. So that's negative 8w. The last positions are these two, negative 8 times 3. And that's negative 24. So what we do is we take all of these and line them up. W squared plus 3w, so I include the signs that they came out to be. So negative minus 8w minus 24. And we look for like terms. These will often be alike. So that's w squared minus 5w minus 24. And that's it. FOIL. The FOIL process. Anytime you see two binomials being multiplied together, you can use the FOIL process. And the next problem, we have another one like that. So we write down FOIL. So the first positions, do you see what they will be? W times W, which is W squared. O for outer, you see what the outer positions will be? W times negative 6. And if you don't need to write that part, that's okay, just write down this part. If you see that already, negative 6W. I for inner, you see what's going to go here? That's 1 times W, which is just W. And then L for last, what will go here? 1 times negative 6, okay? Negative 6. And so line these up. W squared minus 6W plus W minus 6. And these are alike, so we can combine those. So we have W squared minus 6 plus 1, that's a minus 5W minus 6. And that's it, okay? Using the FOIL process is what we can do anytime we have two binomials. Now I've got two binomials again. They're going to start to look a little different, and we use the same process. So if we use first, outer, inner, last, you can just write down the terms, or if you want to write down FOIL and do this, that's just fine. So the first positions give me 4c times c. See that? Which is 4c squared. And the outer positions is 4c and 8. So that's 32c. The inner is these two right here, 5 times c, which is 5c. The last positions is 5 times 8. So that's 40. That's going to give me 4c squared plus 32c plus 5c plus 40. And we can add these like terms. So 32 plus 5 is 37. So plus 37c plus 40. And that'll be it. So let me arrange the slide. I'm not ever sure how much room that I'll need. Same thing with this problem. We'll use FOIL. I use FOIL. Anytime I do this, multiply two binomials, I just maybe don't write FOIL. Everybody uses FOIL, the FOIL process. We just named it here so that we can really see what we're doing. So F for first, that's these positions, 5x times 7x, and that's 35x squared. O is the outer, so 5x times negative 6, and that's negative 30x. And then I for inner, and that's 1 times 7x, which is 7x. And then L is the 1 times negative 6, and that's negative 6. And there's all your terms that we line up and see what we have. So 35x squared minus 30x plus 7x minus 6. And you just look, and usually, not always, you'll see later that you can combine those middle terms. They'll be like terms. So 35x squared, and then you have minus 30 plus 7, so negative 23x minus 6. And that's it. In the next problem, we'll do this again. So let me see if I have room for all of this on one slide. What I'm going to do is not write FOIL. You can do it and line up, write those terms, but I'm going to just write them this way. So the first position, and I'm doing it in my head, F for first, gives me the x's. So that's x squared. I'm just looking at it and multiplying and writing it down. The outer is right here, x and 4y, so that's plus 4xy. And then the inner is right here, negative 4y times x. We put them in alphabetical order usually, those letters, so that's going to be negative 4xy. And then the last positions is where I multiply negative 4y times positive 4y. And that's negative 16y squared. So I look at the like terms that I can combine. I actually have plus that kind of term minus the exact thing, so that's 0. So this becomes x squared minus 16y squared. So these kind of cancel out, and that's it. So sometimes they can combine and make 0. See if I can make this work in another color. So now I'm going to use FOIL, just like I did here, just lining up like that. So the first positions for F for first gives me those z's. Z times z is z squared. See how I put my lines through my z's so that I can tell that it's not a 2? Very important to be able to see the difference with your handwriting. And so next is O for outer, so I have z times negative 3y. And so that's just negative 3yz. The inner, I for inner, is 3yz. So it's a positive one of those, 3yz. And the last one is 3y times negative 3y. and that's a negative 9y squared. And so these two, looks like they cancel out. They just add up to 0. So my answer is z squared minus 9y squared for that one. For this problem, we do the same thing. So the first position, right here, 8u times 8u, that's 64u squared. And then O for outer, so 8u times 9u, that's plus 72, that's 9w. So 8u times 9w is 72uw. And then we have the inner, multiply these two, negative 9 times w times 8u is the same thing, negative 72 though, negative 72uw. And then the last positions is a negative 9w times a positive 9w, so that's negative 81w squared. So we can see these cancel out because they add up to 0. So it'll be 64u squared minus 81w squared. So if you look at that pattern in all three problems, we have the same thing but plus and minus, plus minus, plus minus, and in all of those cases we only have two terms that come out, not three, in our answer. And the next problem is a similar kind of thing, univariate. That just means one type of unknown variable. I'm not sure why we had multivariate first, but we do use FOIL, so the first positions for this problem will give me d times d, and that's d squared. The outer is next, d times 3, and so it's plus 3d. The inner is negative 3 times d, so that's negative 3d. And then negative 3 times 3 is negative 9. And these are alike, so those actually add up to 0. So it'll be d squared minus 9. Now for this problem, the first positions gives me u times u, and that's u squared. The outer positions, u and 5, that gives me 5u. The inner positions, negative 5 times u is negative 5u. And the last is negative 5 times 5, so that's negative 25. And these add up to 0. And so that's what we have left. For this problem, we start with our f in FOIL, first position, 8 times 8, that's 64. And then next is the O for outer, and that's 8 times negative c, so negative 8c. And the inner gives me 8 times c, so that's plus 8c. And the last positions gives me plus c times minus c, and that's a negative c squared. And then you see you have these add up to 0, so your answer is 64 minus c squared. And you can see a pattern in these as well. With these problems, we had d minus 3 times d plus 3, u minus 5 times u plus 5. You see that there's what's called the conjugate, the opposite, 8 plus c times 8 minus c, and look at how the answers came out. They all have subtraction signs, and the third term, the middle term rather, canceled out. There's just no middle term. So they all equal binomials. When we see patterns like this, it helps us to go backwards and factor, which we would usually do next in a math course. And here's some more problems like that. As you can see, there's some more numbers there. Did we do things like this already? I feel like close. Okay, so but we still have plus minus of the same thing, the conjugates. So I bet we'll have binomials, answers with only 2 terms come out. So in this first problem, the first positions, 2y and 2y, give me 4y squared. The O for outer now, 2y times 7, that's 14y. The inner is negative 7 times 2y, so that's negative 14y. And the last is negative 7 times 7, which is negative 49. And these two are alike, and they add up to 0. So the answer is 4y squared minus 49. Next is this problem. So F for the first positions gives me the 2 times 2, so that will be 4. And then O for outer, we're looking at 2 and then negative 5w. 2 times negative 5w is negative 10w. The inner gives me 2 times 5w, so it's plus 10w. And then the last positions, 5w minus 5w, is negative 25 w squared. And then you look at what you have. You have a negative 10w and a plus 10w, so those add up to 0. So 4 minus 25 w squared is left. In the next problem, we use FOIL, so F for first. In the first position, we have 7 and 7, so I'll write that down here, 49. And then the outer, 7 times negative 6a is negative 42a. And then the inner positions, 6a times 7 is plus 42a. And then the last positions, we're looking at 6a times negative 6a. So that's a negative 36 a squared. So these two add up to 0. And this is what we're left with, 49 minus 36 a squared. So see how all of our answers have a minus sign in them, and they're only 2 terms again. In the next problem, we have a couple different unknown variables going on. So let's try those. More FOIL, because there's 2 binomials that we're multiplying by each other. So for the first positions, we have 5z times 5z, and that's 25z squared, because it's z to the first times z to the first, and that's where you add the exponent, so z squared. And then for the outer positions, 5z times negative x will be a negative 5xz. Kind of put it in alphabetical order. In the middle positions, multiply those, you'll get plus 5xz. And then the last positions is x times negative x. So positive times a negative is a negative. And this will be x squared. Now you look at what you have. There's negative 5xz plus 5xz, that's 0. So those disappear or just kind of cancel out. So 25z squared minus x squared. Now for this problem, we have 8z times 8z for our first positions. That will make 64z squared. And for the outer, we have 8z times negative 7x. So those numbers make negative 56, and then we just write xz. And the inner is kind of the same thing, 7x times 8z, and it's plus 56xz. And then these last positions, we're multiplying 7x times negative 7x. So that'll be negative 49. And that'll be x squared. And again, these cancel out or add up to 0. So you're left with 64z squared minus 49x squared. And here's one more of those. I'll actually write FOIL out just so we go back to that in case you need it. Okay, so our first positions gives me x and x. X times x, and that's x squared. Our O for outer is x times negative 4z. X times negative 4z, and so that's negative 4xz. And then I for inner, 4z times x, and that's 4xz. And the last positions gives me 4z times negative 4z. So 4 times negative 4 is negative 16. And then when you multiply the z's, they really have 1's there. 1 plus 1 is 2. Then you take all of this and line it up into your polynomial to see what you have. And you can see those middle terms are going to cancel out. So these two are the same, and minus one of those and plus one of those makes x squared minus 16z squared. In the next problem, we're given this rewrite without parentheses and simplify. So 2 plus 4x squared. So the first thing I'm going to remind you is up here. When you had something like 4 squared, that means 4 times 4. That exponent tells you how many times to repeat that base. Well, here, this is the base, this whole thing. So what we're doing is 2 plus 4x times 2 plus 4x. So you got to remember that part, that this means 2 of those. You cannot just distribute the 2 to each term because there's a plus sign there. If there's a multiplication, you could do that, but you'll never go wrong if you write down basically what exponents mean. 2 of those multiplied together. And then once we have this, you see we have like our FOIL thing we can do. So if we look at the first positions, that's 2 times 2, and that's 4. I'll just write the FOIL terms out that way. Outer is 2 times 4x, so that's 8x, positive 8x. And then the inner is 4x times 2, so that's 8x plus 8x. And then the last positions is 4x times 4x, and that'll be 16x squared. And then we have like terms in the middle, so it'll be 4 plus 16x plus 16x squared. And so that's it. Over here is the same thing. That exponent means we have 2 of those multiplied together, 7 plus x times 7 plus x. And once you write that out, you can recognize you have 2 binomials, and you're going to use the FOIL process to multiply. And so the first positions is 7 times 7, and that's 49. The outer is 7 times x, so 7x. I for inner is right here, x times 7, and that's 7x. And the last positions, L for last, x times x, that's x squared. And these are alike. So 49 plus 14x plus x squared. And that's it for that one. Here's another one like that. So we just write two of these. Multiplied together. 4u plus 7 times 4u plus 7. And then we use FOIL. Okay, so first positions is 4u times 4u, which is 16u squared. O for outer is 4u times 7, and that's 28u. And the inner is 7 times 4u, and that's 28u again. And the last positions gives you 7 times 7, which is 49. So we look for like terms, which I have right here. And so these first and last terms will stay in there. 16u squared plus 56u, and then plus 49. And that's it. Now we've got squaring a binomial multivariate. Just means we have more than one type of unknown variable. We got like a w and a v, but it's the same thing. You're the one who has to recognize that an exponent means we have two of these multiplied together, so you got to write those out and not distribute that 2 to each term inside the parentheses. That exponent cannot be distributed to each term. So you've got to write two of these out and then use FOIL. See this one? This will be the same thing. 3w minus 8y times 3w minus 8y. But back to this one, when we use FOIL, F for first, 3w times 3w is 9w squared. O for outer is 3w times 4v, and so that's plus 12wv. Just put the letters together and put them in alphabetical order. Is that alphabetical order? D, V, W, oh, well, maybe not. And then the inner is 4v times 3w, so that's also 12. I'll just make it wv, who cares? Make it the same so I can recognize that later. The last position is 4v times 4v, so that's 16v squared. So these are alike, and I can combine those. So I'll leave the 9w squared in there. This will be plus 24wv plus 16v squared, and that's the answer. And then the other problem's the same thing, use the FOIL process. So the first positions are the 3w and 3w, and that's 9w squared. Then the outer is 3w times negative 8y, so that'll be a negative 24wy. And the inner is negative 8y times 3w, so that's a negative 24wy. And then the last positions is negative 8y times negative 8y, and that's plus 64y squared. So we just look for like terms, like right here. And we have 9w squared minus 48wy plus 64y squared. In this problem, multiplying polynomials with negative coefficients. So we just have some negative things going on. So we use FOIL because we do have two binomials here in this first problem. So what we can do is look at the 7y and the negative 3y. That'll make it negative 21 y squared. And the outer is 7y times negative 2. And that's a negative 14y. The inner here, these two terms inside, give us 2 times negative 3y, so that's negative 6y. And then the last positions is 2 times negative 2, and that's negative 4. So we just look for like terms, like usual, and combine them. Negative 14y minus 6y, that's a negative 20y, minus 4, and that's it. So for this problem, we have negative 3 times 2 binomials. What I would do is definitely multiply these first. So I'm going to have this negative 3 hanging out with what I do in here. So I'm going to FOIL these 2 binomials first. That's how I would do it. So the first positions, x and x, gives me x squared. The outer is x times negative 8, so that's negative 8x. The inner is negative 3 times x, so that's negative 3x. The last positions is negative 3 times negative 8, and that's plus 24. Now these are alike, so I'm going to combine those and show what the problem looks like so I can see that. So x squared minus 11x plus 24. Now I can see I have to distribute that negative 3 to each term inside the parentheses. So negative 3 times x squared, I'll write what I'm doing here, negative 3 times x squared, and then I'm going to take negative 3 times negative 11x, and then I'm going to take negative 3 times 24. So this will be negative 3x squared. This negative times negative makes a positive, 33x. And negative 3 times a positive will be a negative, so that's 3 times 24, which is 72. And that's it. So for this next problem, it's the same kind of thing. Use FOIL. We have 2 binomials. Some negative things in there. So the first position, I'll go ahead, if this helps once in a while, to write out FOIL. So the first positions is negative 5 times negative 5. Negative 5a times negative 5a. And that's negative times negative is a positive, so it'll be 25a squared. And then O for outer is negative 5a times the negative 4. That'll be 20a. The inner is negative 8 times negative 5a. So negative times negative is a positive. That'll make 40a. And then the last gives me negative 8 times negative 4. And that makes 32. So from that, I can make my polynomial and take a look at it. 25a squared plus 20a plus 40a plus 32. And these are alike. So this will be 25a squared plus 60a plus 32. And that's the answer. So for this problem, we have multiplication involving binomials and trinomials in one variable. So we have a binomial, and we're multiplying this by a trinomial. This is just more work, more distributing. It's not FOIL. So what we have to do is, I'll do this in color. First, we're going to distribute this 2x to each term inside the parentheses next to it. And then we're going to take the negative 3 and distribute it to each term inside the parentheses next to it, and just line up all those terms that we get and write it down. So I'm going to write it out. So first we're going to do 2x I should color coordinate this. Let me make this in red then. So what I circled in red, we're going to do in red. 2x times x squared. And then we're going to multiply 2x times negative 4x. I can see I'm going to have to get rid of this problem so I have more room. And then 2x times 5. And then what we're going to do, I'll put it in this blue or it won't show up too good, is distribute this negative 3 to each term. So negative 3 times x squared, and then negative 3 times negative 4x, which I get from right here, and then negative 3 times 5. Let me move this problem to another slide real quick. Okay, so we have this problem we've been working on. Now I'll just write it all in red, I guess. Maybe white, I don't know. So now I'll write what my problem looks like. 2x times x squared, that'll be 2x to the third, because we add those exponents. Positive 2x times negative 4x, that's going to be a negative 8x squared. And then 2x times 5 gives you 10x. And then here you just have negative 3x squared. Negative 3 times negative 4 is a positive 12, and you have that x. And then here we have negative 3 times 5, which is negative 15. And you just look for like terms. 2x to the third is by itself, so I used that already. Now I have a couple x squared terms here, negative 8 minus 3, that's negative 11, x squared, this and this I used up. Now I have a couple x terms, 10x plus 12x, so it's plus 22x, and it looks like minus 15 is hanging in there as well. And that's it. I'll do another one like that. So it's the same thing. It's just now we have the 2u minus 1, the binomial on this side. So what we're going to do is distribute this 2u to each term in the parentheses next to it. And we're going to take that negative 1 and distribute it to each term in the parentheses next to it. So first we'll distribute the 2u. So it's 2u times 4u squared. And then it's a positive 2u, so plus 2u times that negative 5u. And then 2u times the negative 7. And I'm going to switch to green so I can, some sort of green, so I can show what I pointed to in green here. So it's negative 1 times that 4u squared. Okay. Negative 1 times the negative 5u. Come on, internet. And then the negative 1 times the negative 7. So I distributed that negative 1 to everything. Now I'll just use white, I guess, to combine these, or to actually multiply them. So 2 times 4 is what we look at here, 8u to the third. And then here we have positive times a negative, so that's a negative. 2 times 5 is negative 10. U times u is u squared. Here, positive times a negative. 2 times 7 is 14, so negative 14u. And then here we have negative times positive, that's negative 4u squared. And then negative times negative is positive, 5u. And then negative 1 times negative 7 is a positive 7. And then you start to combine like terms, And this 8u to the third is by itself, so I used that up. I have a couple square terms here. Negative 10u squared minus 4u squared is negative 14u squared. So I used those. Then we have a couple u terms here. Negative 14u plus 5u is negative 9u. And then that plus 7. That's it. And that's the answer for that. Just 4 more problems left. I think I've got another one of those, so we'll try that. If you don't need that, you can go on to the next problem. So I'm going to circle what I'm going to do. So I've got a binomial times a trinomial. So I need to take that 6x and multiply it by each term in the parentheses to the right of it. And then I'm going to take that 4 and multiply it by each term in the parentheses here. So we start with 6x times 2x squared. And then plus, since 6x is positive, plus 6x times 5x. And then plus 6x times negative 1. Then in blue, 4 times each term. So plus 4 times 2x squared plus 4 times 5x plus 4 times that negative 1. So to actually multiply that out, which you might not have to write this whole step, that's just fine. You can just look at it and do it, or cover part of the problem up and do it. Some people need to write that down or like that much better. So 6 times 2 is 12x, and that'll be to the third. 1 plus 2. And then this is 6 times 5 is positive 30 there. X times x is x squared. Then you have positive times negative, which is a negative 6x. Then we have 4 times 2x squared, that's just a positive 8x squared. And then 4 times 5x is positive 20x. And then 4 times negative 1 is negative 4. So I'm looking for like terms, and again, the x to the third term is by itself. And then we have a couple x squared terms here. 30x squared plus 8x squared is 38x squared. And then we have negative 6x plus 20x, so that's plus 14x. And then the minus 4. So that's how to multiply a binomial times a trinomial. Now we have more of this, multiplication involving binomials and trinomials with 2 different kinds of variables. So when you're multiplying 2 different kinds of variables like we've done before, like x and w, x times w is just xw. And so now let's try to just eye this, where I'm going to multiply 3x times each term in the parentheses, and then the 3 times each term. So I'll write that out, what I'm doing. 3x times 2x plus 3x times that negative 4w plus 3x times that negative 1 inside the parentheses. And then I have 3 times each thing. So that's plus 3 times 2x, and then plus 3 times negative 4w, and then plus 3 times negative 1. That is a string of algebra right there. And so 3x times 2x is 6x squared. And now we have a positive times a negative, so we'll get a negative. 3 times 4 is 12, and then xw, so we just write down xw. And 3x times negative 1 is negative 3x. 3 times 2x is plus 6x. 3 times negative 4w, that would be negative 12w. And then 3 times negative 1 is negative 3. So we look for like terms. Make sure I didn't miss an x and w anywhere. 3x times everything and then just 3. Okay. So we have got this 6x squared term that's by itself. So I used that. Looks like we just have a negative 12xw by itself. So I used that. Now I have x terms right here, negative 3x plus 6x, that's a positive 3x. And then these terms are alone, and that's it. Minus 3. And so that'll be it. Looks like we're doing the same thing for the next problems. So what I'm going to do is start with the 6y. I look in the binomial, and I'd start with the 6y, multiply it by each term. So I'm going to write that down. And then what I'm going to do is multiply that negative 4u by each term and write that down. So 6y times 5y plus 6y times negative 3u, and then plus 6y times negative 1. Now I'm going to take that negative 4u and do that to the same thing, to the same way. So it's negative 4u times 5y and negative 4u or minus 4u, same thing, times the negative 3u and then negative 4u times negative 1. To actually multiply them out, this will give me 30y squared. This is the plus times the negative, so I get a negative. 6 times 3 is 18. That's uy, I guess, to put it in alphabetical order. And 6y times negative 1 is negative 6y. And then we have negative 4u times 5y, which is negative 20 uy. Then we have negative 4u times negative 3u, so that's a plus 12u squared. And then we have negative 4u times negative 1, that's plus 4u. Now I look for like terms. So it looks like this y squared term is by itself. I've got a couple uy terms here. So negative 18uy minus 20uy is negative 38uy. So I used those. Looks like negative 6y is by itself. And all of these are by itself, I guess, as well. So plus 12u squared plus 4u. So all of that is your answer. One more problem here, we'll do the same thing. So I'm going to take this 5u and multiply it by each term inside the parentheses, and I'll write down what that looks like, just like I've been doing. And then I'm going to take that 7 and multiply it by each term inside the parentheses. So 5u times 5u, now 5u times negative 3y. Then 5u times that 2. And now I'll take the 7 times each term. So it's plus 7 times 5u. And then plus 7 times negative 3y. And then plus 7 times 2. And now we'll actually multiply these out. So 5 times 5 is 25, and that'll be u squared. And then plus times a minus is negative 15 uy. Then we have 5u times 2, that makes 10u. And then 7 times 5u is 35u. Then 7 times negative 33y, sorry, is positive times negative is a negative 21y. And then you have 7 times 2, which is 14. So now I look for like terms. Looks like the u squared term here is by itself. I have a uy term here by itself. Looks like these are alike, so 10u plus 35u is 45u. And then these two terms, 21 minus 21y plus 14. And that is the answer for that. I hope that helped you. So review and pause parts if you need.